Welcome to the welcome to the statistic learning session. Today we'll be talking about chi-square test. Last part we talked about the maximum likelihood estimated for this in our earlier session. Now, what if we're not using maximum likelihood estimator? What would happen? Would be the wrong answer. Let me show you. Now we know that when we divide nj divided by n, then it gives us the probability p hat j. Now n is a total sample and n j is a small subset of the n. Now we can think about it as a this being n as a binomial distribution where n is a population and probability p j dash as a population probability distribution of nj divided by n. Now can you tell me that if you can apply central limit theorem to this binomial distribution? Think about it. Yes, we can apply central limit distribution to this binomial distribution, and when we do that, it becomes p hat j minus p naught j divided by pj minus 1 minus pj and it's going to be p naught and square root b, it would be multiplied by square root. If we do this, then this should give us the normalized version of the it should know binomial distribution, and this should eventually equal to a standard normal distribution 0 1 n equal to infinity, and it can be a d. Now what if we square on both sides? What would happen? Think about it. If you square on both sides, then it would give us a n root becomes n, and p hat pj naught becomes p square, and it would give us pj 1 minus pj, and this is equal to square of normal distribution, which is a chi-square with 1 degree of freedom. Now if you're supposed to sum this all chi-square, then it would give us k degree of freedom, right? Well, this is wrong answer, because what we need is a k minus 1 degree of freedom, not k degree of freedom. Now also we need to be careful is that what we're normalizing it by here. We are normalizing it by pj 1 minus pj, and this is a wrong normalization. It should be just pj instead of p, instead of what we have here. It should be a pj instead of pj minus 1 minus pj. So it's a wrong normalization as well. Therefore, when we normalize separately numerator and denominator, it gives a wrong answer. So it's a joint convergence of p hat to pj This is an important issue here, and it sums to 0. So something's really happening here of joint conversion of numerator and denominator, and that's what we'll talk about in later course. So let me quickly sum up what we learned today. We learned about the chi-square and what happened if we separately normalize, separately converge the numerator and denominator, and it was not giving us right answer. It was giving us the giving us the uh, freedom of k degree of freedom, and it was not the right answer. And we're also getting the wrong normalizing factor. So that's all for today. I'll see you next learning session. Thank you so much.